All right, well, welcome everyone to the Residence Academy virtual classroom. And this is our Winter Solstice Live with Nassim session. My name is Teresa Collins, and I am the Academy Director. And we host these kind of virtual events like this every month for our delegates. And we currently have 3 main sessions that they get to enjoy. The first one is like this, a Live with Nassim, where we get to hang out with Nassim for 2 hours, asking him questions, getting updates on the research. Really a fantastic aspect of our virtual academy. And then we have our faculty Q&A sessions where you get to hang out with the faculty and our researchers and ask questions of them. Super lively sessions, and it's a really great opportunity for us to see what the delegates are learning by the kind of questions that they ask. And then the last kind of event that we do is a video-enhanced breakout group. And that is where our delegates from all around the world get to connect with each other and discuss what they're learning and how they're applying what they're learning into the heart of their everyday lives. And these also provide a really lively space for our learning community to engage in the exploration of unified science with Nassim and the research team from the comfort of our own home. Like right now, I'm in Costa Rica. I came here with my family, get to join this session with all of you today, and we get to join from all around the world. So these sessions are really an amazing part of one of the benefits that the Academy delegates get to enjoy, and we're always excited that on every equinox and every solstice, we open these up to our friends and new and longtime fans and our supporters so that we can share updates with you and that you get a chance to see what it feels like to be inside of the Academy. So on behalf of the entire Resonance Academy team and our growing global learning community, we welcome you to the virtual classroom. And I'm going to go to Nassim first and just have him give you a quick hello, and then I'll give you an overview of our call today. So here we go. Nassim.
Hi.
Always great to be with you on these virtual Live with Nassims, and I love when we get to open it out to the public and everybody gets to come and play with us because we have so much fun on these calls.
Yeah, it's awesome. I was looking on the chat. There's people from all around the world, Switzerland, everywhere, and it's great to connect with everybody like this. It'd be awesome if it could be in person, but we're gonna need gravitational device before that happens. I'm working on those. It's always amazing as well to get the community questions. There's so many great thinkers out there and good questions and so many different subjects to talk about. And it's great to, be surprised, with you never know what's coming next. And it makes me think. It makes me think about many different things. And it opens it up for all of the community to think. And certainly, for people that are involved in the delegate program, it's really good to be able to read the delegate program and study it and then come up with questions and then have them answered or have them discuss, together and, participate in the community and build the community across the world. Makes a huge difference. And certainly, it promotes a change in the world. So it's a participation that's important. We're all getting educated at the same time, and we are all, growing together. And that's really the most stimulating and important part of our community and our goal in the world. So, it's exciting to have these and to see the interest and see the participation. It always warms my heart and keeps me going in the dark moments of research and development.
Yeah, thank you so much, Nassim. Every month Nassim gives us these 2 hours like this, and I know it's often difficult in the middle of the research and work that he's doing, but he always shows up for the community. And I know by the end, Nassim, that you feel really fed and supported by being able to engage with the students. And aren't we tested by the quality of the questions? They're really starting to get, whoa, really good. So yeah. Before we start into the call, I just want to say, if you're joining us on Zoom, you'll see that there is a chat, and we love to hear from you. Like, say who you are, where you're calling in from, and let us know if you're a delegate or whether you're just new, a fan out there. That way we know. And if you're on Facebook Live right now, use the post to do the same thing. Let's see who's here listening from Facebook as well. And there's going to be three main sections of this call. And the first one is we want to give you some updates. So we brought Brian Anderson, who's our new executive director. Nassim's going to share a few things, William Brown, and we're just going to kind of give you a little sneak peek of what's kind of coming ahead, and also kind of what we're proud of that's been happening in this last year because of your support and participation in the research, right? And then the second part of it is our general Q&A session. This is what we do with Nassim every month, is that we get to ask him questions. So those of you who are on Zoom, you're going to use the question icon down at the bottom. It's like a little folder, and that's where you're going to ask your questions. Don't ask them in the chat. It's too hard for William to try to figure out questions if they're in two places, right? So we put our questions there. And Jamie Janover is over monitoring Facebook Live for us right now. So if you want to ask a question from Facebook Live, we're going to have him pull a few of those questions in so that we can hear from you on Facebook Live also. And then we're going to have just a little time to share with you some of the ways that you can participate with us right now and with what we have going ahead. And Nassim will close with a little visualization to support us on this beautiful winter solstice day, and as we start to lead in to the new year and really coming forward as a community together. So I am going to start first with Nassim before I bring and introduce Brian Anderson to you. Nassim, why don't you share some of the things that you're excited about that we accomplished last year? And I know you were saying there's some things you can't say. Why don't you give us a little update?
I know you put that on the agenda, and I'm like thinking, oh yeah, I could talk about that. Oh no, I can't talk about that. Oh, I could talk about. Oh no, I can't talk about it. So I'm definitely excited about a lot of things, and some of the things are very theoretical. A lot of the things have to do with what we're building in laboratory. Other things have to do with what we're doing in archaeology research and some of the stuff that I'm involved in, and it's always super exciting. And Indiana Jones kind of stuff, and as well, I think that in general, there is, well, first of all, there's things I've done in theoretical physics that I'm really proud of and excited about, and that is we finished the electron paper, and we finished the cosmological paper. And the cosmological paper I had been working on almost since 2013. And it's not that I was working on full time on it. It's just that I was waiting for the appropriate opportunity to publish it, and as well, kind of cleaning up some of the work in there. And when we were cleaning up the work, we found deeper levels of solution to the mathematics that are extremely precise results for universal mass, for universal expansion, for what's called critical mass, that is the mass of the universe in terms of the baryonic mass, the dark energy and the dark matter, so-called dark energy and so-called dark matter. That is the total mass of the universe, the mass required so that the universe behaves the way it behaves, which in the standard model, they have to fudge almost 96% of the mass with dark matter and dark energy. In this new solution, that comes out straight out of first principle. So that means it's not required, to be added as a fudge factor. And so it's really exciting, and it comes out extremely precisely to the right value. So, it's interesting because it shows that from measurements and certain models, we've been able to appropriately, give the correct expansion rate, or at least the correct mass for the universe, but that, the model that we're bringing forward is telling us something vastly different about the universe, and our place in it, our relationship to it, and matter production and universal production. Matter is not a production of a movie by Universal, but the universe is being created, and the creation of universes, and the multiverse and so on. So that I'm really excited about. And then there is a lot of things we've been doing in laboratory that is will be coming out soon, and including at ARC with the ARC crystals, and getting a lot of data in the laboratory from hundreds, thousands of tests that we're doing with various devices, to describe the impact of the crystal vacuum interaction that we are creating in these technologies. And there is as well really exciting stuff that's coming out, just as a side note, from the mainstream. If you're gonna ask me a question like that, Teresa, you gotta be ready for a long answer. But
Good, I'm glad. We want to know.
So there's research that just came out showing that crystal vacuum interaction are very important from the mainstream and so on, and that we need to understand them. The talk from, and one of my highlights for this year is a talk by Frank Wilczek, that he did in 2017 actually, but that I just became aware of this year, and called the materiality of the vacuum, where he trades up. And Wilczek is probably one of the most celebrated physicists in the world. He holds a he's a Nobel Prize laureate. He's written some of the most important physics, according to many, in the last few decades. And so, his talk on the materiality of the vacuum is remarkable, because it's literally a break into a new level of physics that resembles very much, if you take one of my presentations from about 20 years ago or 15 years ago, very similar in terms of describing space as a material which is oscillating with what can be called phonon, which Dr. Rauscher and I wrote papers on in the earlier times. And that he literally calls us children of the ether, and shows clearly from this presentation that removing the ether theory was a big error in the evolution of modern physics. And so it's a very important talk. Then as well, we've done, of course, there was the Peru trip, which was tremendous, remarkable, and all the amazing things that we were able to do there and see, and being there with the crystals and all the things that happen, and traveling in third world countries with 150 people was epic, and definitely quite the mission, and definitely it wasn't a vacation, but it was a mission, and I think it was mission accomplished. And so we are happy about that. And there's lots of other things that it would take too long to describe, but there's been advancements as well in our structure of the foundation, which is about to get a serious upgrade and facelift, because of the implication or the involvement of our new CEO, which I'm super excited about. And that'd be Brian, which is on the call today and that you'll hear from in a few minutes. So I think that was a notable thing that happened this year as well. So it's been an amazing year, and I'm sure that 2019 is gonna be like over the top.
That's for sure. Thanks, Nassim. I know I'm going to put a link to a letter that we wrote actually that had some of the highlights from it. I'll put it here so that people have it if they haven't had a chance. And before I go to Brian, I'm just going to see if William wants to add anything, because I know there's been some great research on the water that he's been super excited about. So let's see. This is William Brown, and William's going to be helping today with us because so many questions come in, and William's going to be the one that's going to kind of choose the direction of the conversation later for us. So thanks for coming on, William. And is there one thing that you might say that you want to add to some of the exciting things happening with the research team?
Well, thank you, Teresa. It's always fantastic to be able to participate in these live Q&As. I thoroughly enjoy the ones we have for the Resonance Academy faculty. And then I especially love the ones with Nassim because, like all the other viewers, I get to learn a tremendous amount hearing the discussions unfold. And so 2018 has really been a phenomenal year for our organization, our research, major breakthroughs. There's some things that have come together that I think we've been looking forward to achieving for many years now, and they came to fruition in 2018. A particular highlight was we presented data at the 2018 water conference in Sofia, Bulgaria, that's hosted by professor at the University of Washington, who is fairly renowned for his work on structuring water and fairly anomalous effects of water. He authored the book called The Fourth Phase of Water, Gerald Pollack. At the conference, we were able to present some of the measurements we've been doing with the arc crystals, and it was very well received. And the data itself that we presented is starting to give us a more detailed understanding of how this technology has the effects that it does, as well as to more fully characterize what those effects are from this crystal. Because at this point we're now being able to probe at the molecular level what the crystal is doing in substances exposed to its field of interaction. And I guess as a side note to that, some of the measurements that we're doing around this involves keeping track of the lunar phases, other astronomical cycles, the position of the Earth around the sun, because it's very possible that the effects are influenced or being occurring in conjunction with lunar phases, tidal forces, gravitational interactions, things of that nature. And so we've been monitoring the phases of the moon, and I was pretty astounded or surprised to find out that on the solstice, we have nearly a full moon. It seems pretty auspicious there. So tonight we're eagerly awaiting data that's coming in from the lab because at about 10:30 PST time, Pacific Standard Time, where we're at, we're going to be at maximum solstice, and the moon's going to be 98% full. So we're very interested to see what that astronomical alignment, planetary and solar and moon alignment is going to do to our equipment, our measurements, which are sensitive enough to pick these kind of effects up. But I'm sure that this kind of alignment has fairly profound effects on all of us. So it's kind of an auspicious state, and I'm very happy to be here with all of you on it.
Nice. We'll be thinking about you guys tonight. I'm sure we'll have a little impact on the results as well as a community, right? And we also launched 4 electives, and Williams was one of them. Big questions, resolving the hard problems of science. Fantastic elective. And we had 3 others too, with Robert Grant, another one with Jamie Janover. We just had a really powerful year, and we extended our research team as well. There's now, I think, 6 researchers on the team. So we're excited. And thanks, William, for all your work with the water. So I'm going to introduce Nassim, do you want to introduce Brian? Do you want to say, I know you said you're really excited about having him, but do you want to say anything else about Brian before I bring him on?
Well, I just think that it's fantastic to have him on board and, steering the ship at the foundation. It's been a lot that we were handling, Chris and I, over like 3 organizations, and Brian showed up just on time to like bring the bow back up, above the seawater level, so that we can take a breath. And so I'm really, really happy to have him on board, and I'm happy to see the foundation. Where the foundation is gonna go is very, very exciting as a result of this steering, and I'm wanting to I'm elated at the support that's coming as a result of what's going on at the foundation.
Great, thanks, Nassim. So Brian, I'm going to spotlight your video, and yes, I just want to say it's exciting to have Brian on board and really building on so much of what this core community has been able to happen so far, but now needs in order to really go to the next level. So Brian, happy to have you on board, and maybe you can give us a little sneak peek of what's coming and a little bit about yourself.
Sure. Thank you, Teresa. And Nassim, I can't ever thank you enough for just being yourself and the movement you've done with unified physics and just changing the world in that position. And that's actually what attracted me to this organization. I've been a successful business executive for 30 plus years. I've got over 5 million miles on airlines. I've pretty much spent time in every country and every continent except Antarctica. So I understand the unique nuances of the different cultures and places, and really am super excited about taking the foundation to its next level of growth. What you're going to be seeing in early January is kind of a relaunch of the foundation. There'll be a new logo, there'll be a brand new website, but more importantly, we're expanding the foundation more literally. We have always talked about different elements beyond just science, but we're going to now codify that we are the intersection of science, community, and consciousness. And you'll see more content and more research around the intersection of those 3 things. Obviously, heavy focus on science and all the exciting things that Nassim talked about, but how that impacts community and the archaeology and the history, and how that impacts consciousness and the way we think. And fundamentally, it comes down to our core belief. We believe that everything is connected. We have the science to prove it and the tools to experience it. And the new website will help you with that. But more importantly, in the early year, probably in kind of mid to late January, we're also going to be launching a new Resonance Science Foundation app. And that app will give you access to even deeper science and more collaboration with the scientists, but even more importantly, more collaboration with the rest of the community, and give you the ability to share some of your thoughts, your ideas, your projects, your science with us and with the rest of the group. And the idea, of course, is to make it very easy for us all to communicate and collaborate across all of the fronts And that app will make that very easy for you to do as a community. So in addition to the website and the app, I'm also excited to announce that we'll be launching the French versions of everything in the beginning of the year as well. Obviously, we have a huge audience in France and French-speaking countries, and I'm super excited to be able to announce that we will be launching native French versions of the Academy and the content and even the website in the early parts of the year. As you know, we're a nonprofit foundation, so the way we fund the science and the research are through your generous donations, your support of the Academy, obviously your support of the coming app, but also through the trips. Nassim mentioned that we just got back from a fantastic trip in Peru and Bolivia. These trips are so exciting that we're going to start doing some different things next year. So in 2019, there's going to be 3 major opportunities to basically come together as a community. The equivalent of Peru last year, or this year, and Egypt last year, in 2019 will be Mexico. And the idea is to, once again, bring the community together in the fall and really sink in with the Incan pyramids and the Mayan cultures. And once again, that intersection of science and community and consciousness as it relates to this very important location. The other thing we're doing is in July, we're going to have our first ever delegate retreat, and that will be in Santa Cruz. And you'll be seeing more information on all of these events. But the Santa Cruz will be a unique opportunity to once again get together with the group over a period of time, share your ideas, get more interaction with the scientists and better understand, what we as a foundation and a community are doing for the betterment of the world. And then the other trip that I'm very excited to announce is the introduction of something we're calling the Master Series. So this is kind of modeled after Tony Robbins, and Nassim just had the privilege of speaking at one of Tony Robbins' events in the Middle East. And we're finding now that there is a need for a master series. So we're going to introduce the concept of a master series, and this will be a much more intimate setting. It will be, unfortunately, a little bit more expensive. The idea, obviously, is that we're looking for people who are genuinely looking to take the leap to those next levels of unified physics and resonant science. So we're going to start the Master Series with a trip to Easter Island in the April timeframe. And you will be hearing more details about this in the coming weeks, where we'll start taking deposits. We know this trip is coming up fast, but the delegate retreat in July, and then the big trip for Mexico in the fall. So all of these things are just ways that we at the foundation create funding for the research that allows you to have the discussions that I'm going to now turn it back over to Nassim and Teresa and William on. But I just wanted to end with a thank you for your support for the Academy. I will look forward to working with you as much as possible, but more importantly, look for the exciting things that are coming in early January to really take the foundation and the community and bring it to a whole new level so that we can interact and really show the world what it is capable of doing, and the vision that Nassim has brought and the reality that we can make of it. So thank you.
Thank you so much, Brian. We're really happy to have you on board, and it's going to be exciting to start rolling out all of our new events and activities this year, and invite everybody to engage, right, Nassim? Like, we need to get everybody engaged. I was just thinking about how challenging it's been for you to, get your work acknowledged in the science community. Like, that continues to be a frustration, right, for us all the way around. And I think
I should mention, Teresa, I apologize for jumping in. One of the other things we did was we brought on a PR agency, and you will start seeing Nassim and the scientists' research in major publications. In fact, I don't want to kind of spill the beans of the surprise yet, but in the next couple of weeks to early months, you will see us being much more visible across the publications. So.
Yeah, thanks, Brian. And as you see those things, be sure to share them out. But Nassim, where I was going with that was, I think one of the things that we talked about as a board and had helped guide some of this new direction is that there is a huge groundswell of people in the world who actually feel more resonant with this science and these ideas because it's so close to their own experiences, they open to them. So I think that's going to be important that we have this kind of combined effort. One, we get things out in some of the science journals more and more with the help of a PR firm. And then it's going to be up to this community to really help us grow this learning community, because the upswell that's going to come is going to force, right, this old way to start to dismantle. And I know that you've been feeling that, and I'm excited that we all get to participate in making this happen.
Yeah, I mean, you know, it's one of the things I was going to mention after what Brian said, which is all very exciting, is that you know, the part of the new structure of the foundation is going to make more accessible and more apparent the work that I'm doing with scientists all around the world in our research group that's happening in the background, and that people don't necessarily have direct access to or hear about. And so, I mean, we meet, you know, like almost weekly, you know, at different levels and so on. And so, and so the scientists involved that have been in the background, and, you know, there's people in France, there's people in Germany, there's people in England, in Italy, in South America, you know, in Mexico, so on. So it's like this is going to become more front-facing, and people will be able to interact with us better. We have intent to putting stuff up, like, for instance, you know, Wilczek's talk, which is brilliant, you know, and to like really kind of bring that forward and discuss it with the community and see and engage the community in scientific discussion at all levels of science. And that includes, you know, consciousness and whatever, in various different structured environment that we are planning and working on, so that you can interact with the group as well as interact with the individual scientists involved, you know, as we move forward together and learn.
Yeah, thank you, Nassim. Hey, so we're going to go to the Q&A section of this. So we have a good like hour where we can ask you questions, which is never long enough, 2 hours, and we're just getting going. So we're going to get started on that. Again, if you are here on the Zoom line, you want to put your questions in the Q&A area, and we have got quite a few questions in there that William's going to be weeding through. And if you're on Facebook, put them in the post there so Jamie can identify a few of them. And if you are on Zoom, we'd like to bring your face onto the screen. We're going to pull you in as a presenter. If you don't want to have your video, just leave your video off, and I'll just know you don't want to be seen. Otherwise, we like to say hello. We like to see if the answer fits for you, if you have any other questions that you want to ask related to it. And it just gives us a chance to really feel all of you out there. So I'm going to go to William first. And William, where are you going to start us off? Where has this community actually started us off in this discussion today?
I think I've got a good one here to start us off. This is from Eddie Wares.
Did you say the name again? Sorry.
Eddie. He's 12 years old.
Oh, so you know him, Nassim?
And no, I just saw that question. I thought it'd be a great question to start with, and so I was glad you picked it.
Yeah, it's a great question too. I mean, I'm interested. I'm interested to hear the discussion. But did you get the name, Teresa? Eddie Weirs?
I did. Thank you. I'm pulling it up now.
Okay. And he says, hello, I'm 12 years old. I was curious, how do we know the Big Bang actually happened?
That's a great one.
I'm looking for Eddie here. I'm going to find him.
Okay. Well, you know, it's a good question, actually. and it's really not an obvious answer. That question has been posed to scientists, physicists, and has been the center of investigation for physicists since a very long time. Hi, Eddie. It's nice to see you.
Hi.
Nice to meet you.
Pardon?
Nice to meet you.
You too.
Where are you?
calling from, Eddie?
Canada in British Columbia.
Oh, my old turf. I'm leaving for Canada tomorrow, going
Really?
skiing in Whistler.
Oh, cool.
Yeah, with the kids. So that's why I'm not at the lab, and that's why I'm not in a lab coat right now. But because I'm packing. But it's really a good question you're asking. You see, the theory of the Big Bang was really a very big step in the evolution of cosmology and cosmogenesis. Before that, it wasn't really clear, if the universe was, a constant state universe, or if it all of a sudden bang into existence. And I'm afraid that we've taken, we've made an inappropriate interpretation as a result of some of the data that we've been gathering in cosmology. So what I mean by that is that we can't be sure that the Big Bang happened. Absolutely not. There's not a way that we can certify that it happened. All we can say is that when we look back in time, because, when we look at the stars, we're looking back in time, right? You know that? Because because it takes so long for the light to arrive to us. So light that left from a few billion light years ago, takes a few billion years to get to us, right? So, so if you think about looking back, at a distant object further and further, you are looking back at the beginning of time, at the beginning of the universe. And since the universe is expanding and we have, evidence that it expanded throughout that time, we can imagine that the universe shrunk as we look back in time to a point in space that all of a sudden expanded or exploded into our space-time reality.
Yeah.
You understand that, right?
Yeah.
However, there's a large assumption that's made because, you see, you can't really find where it started. You can get really, 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 really close to it. But at one point, it's something that's beyond what we can measure. It's a singularity. It's a point of infinite density. Imagine the whole universe in a point, teeny point that's smaller than the atom by billions of times, right? It's called a Planck length, a very, very small point. And according to the Big Bang, everything came out of that. But we cannot, write physics on the singularity because there's infinities involved. So we can only write physics on this very, very next billionth of a billionth of a billionth of a billionth of a second after second zero, right? You know, so we don't know that it happened. And part of the experiments that they're building, like the Hadron Collider in Switzerland and so on, is to try to reproduce the conditions that were there very early universe to try to understand it better. The difference between the standard model of the Big Bang, which, you know, is being debated very much right now, and the model I've brought forward, is that in the model I brought forward, it says that the universe is always Big Banging. It's Big Banging everywhere, meaning that it's a constant creation universe, that the universe is like bubbles within bubbles within bubbles of larger universe, and all the stuff in one universe is just smaller and smaller and smaller bubbles all the way down to singularity in each one of those universe. And the singularity bubbles of each one of those universes like the pixel that makes that universe. And you know, you could see the pixel, you could see our universe as a pixel that makes up a very, very large universe, much larger than ours, for instance. You understand that principle?
Yeah.
So it's more like a fractal universe kind of thing. And the universes are not parallel, they're embedded within each other, right? It's like bubbles within bubbles.
Yeah.
Okay, so then you can imagine that, and this is the paper I'm attempting to publish in astrophysics right now. There's no mathematical error in it, but they're still giving me a hard time. In general, what it says ultimately is that, you know, imagine a little bubble, a really teeny bubble in one size universe. Like, let's say it would be like a proton, the nuclei of an atom in our universe, right? Would be the bubble, and the bubble it's coming out of is the bubble of our universe. Okay, can you imagine that? Okay, yeah. Now you can imagine when it goes from our universe to the larger universe that it's in, right?
Yeah.
When it goes from, it would go from one density to a different density. The density would drop, right? When it gets in the bigger universe. You get that? Yeah. So that would make that little proton expand. That bubble that just got out would expand because it wouldn't have the pressure of the higher density anymore. So it could just blow up.
Yeah.
And so when it blows up like that, it could blow up to being another bubble that's the size of the universe that it just escaped. So it just made a universe.
Yeah.
And the inhabitant of that universe would say, oh, our universe is expanding. And they would look back in time and they would see it shrink like when it was a little bubble proton, right? And
right.
it would think there was like some kind of explosion or Big Bang or, you know, something like that started their universe. But in fact, it's just because the little bubble they were in, the little bubble expanded because it changed density when it went from one size universe to another.
Yeah.
So that's a new view of the Big Bang. Now, why is this more feasible? Well, because the math that I'm writing is saying that that comes out to exactly the right values for the critical mass of the universe. That is, the mass of the universe, baryonic mass, is like the mass of matter plus dark matter plus dark energy. It comes out with the right value without having to add dark matter and dark energy artificially. It comes out with the correct value for the mass of our universe. So it's since the dark matter and the dark energy in the Big Bang model is almost 96% the mass of the universe as a fudge factor, My equation and my solution is 96% more accurate than the standard Big Bang model view. So I'm saying to you, there's a good chance that the Big Bang never happened, not in the context of the way it was described in the standard theory, but it's more a change of density of fractal bubbles in a fractal universe that made up our universe.
Yeah.
What do you think of that, Eddie?
It's pretty cool. My dad has said sometimes that we don't exactly have like 100% proof, right? And then at our library, there was a guy that worked at astronomy, and I kind of asked him. He just kind of explained how the Big Bang happened, right? So I went on YouTube and I couldn't exactly find anything, but yeah.
Okay. Well, there you go. Well, you're interested in science.
Yeah.
Oh, awesome. We need help. So keep going,
Okay.
and then maybe you can join my research team.
That'd be cool.
Hey, Eddie, are you part of the Resonance Academy yet?
Well, we kind of are. I homeschool, so we use our funding for the accountant. We used our funding to get the accountant stuff, so we use teacher's name and stuff. So we do have an accountant stuff, yeah.
Okay. If you put your email address in the chat for me, I'm going to send you a link so you can invite one of your friends to also join you in the academy that might be interested, okay, as my guest, okay?
Okay. My mom and dad's email address is
Don't say it there.
Yes.
Why don't you just have your dad send it to me? And it's Teresa, Teresa, at resonance.is. And I'll make sure that you guys can join a friend, okay?
Okay, so what was that again?
Teresa, Teresa, Teresa.
Teresa.
At resonance, RESONANCE.
At resonance, RESON.
ANCE.
Just resonance.
Yeah, ANCE. Okay.
IS. All right. Thanks, Eddie, for coming on. We're glad you're with us.
Okay. Yeah.
Nice to meet you.
Bye.
That was great. All right, William. I bet you got another question all lined up for you, and I'm sure Jamie's been sending you a few from Facebook also.
We've got the questions coming in, that's for sure.
All right.
And I think this one is a fairly important topic. And this comes from Warren Scott Fentress, who's asking, do you ascribe to the Copenhagen interpretation in quantum mechanics? And what does this mean for quantum consciousness or future memories, these kind of things? I was thinking you might have something to say about that.
I think this is a leading question from William. Yes, the Copenhagen interpretation. Well, this is in relationship to consciousness. It's common that people associate, or try to explain consciousness by citing the Copenhagen interpretation. Hi. Uh-oh, you got to wake up.
I'm lying down on my bed. That's all right.
Hi.
Great.
Nice to meet you.
Yeah, we've talked before, Nassim. I'm the inventor of Magna Blocks. I think we talked.
Oh, yeah, I remember.
Yeah.
Oh, yeah. Where do you live?
Connecticut.
Connecticut, right on. Yeah. Well, it's a good question. So the Copenhagen interpretation, I think has misled the scientific community for a long time, and now it has tendency to mislead people that are working on trying to find a source for consciousness by citing it as some kind of evidence that consciousness is involved in matter production, or at least in particle interactions. And I, like, not only would I disagree with that, but the mainstream would disagree with that, and that's why it's not getting any support from the mainstream, is because there's actually nothing in the Copenhagen interpretation that says anything about consciousness. People misinterpret the concept that a measurement is done to, or an observation is done to, that means that consciousness is making a difference in the experiment.
The observer and the observation, right?
Right. Of course, consciousness has an impact on matter. When people make experiments to prove that, I always chuckle a little bit and I say, look, I've done my own experiment. I'm influencing matter. Check it out. Billions of atoms, right?
Yeah.
But I would like, I just mean that, like, okay, so let's look at it in more detail. So the interpretation does not in any way, shape, or form, in its mathematical form, say that that the observer must be a conscious observer. It could be a computer making a measurement with nobody, involved, not even watching the screen or in any way. Never mind that computers have been shown to be modified by consciousness, but that's another story. But what I'm saying is that so the idea came because this very specific experiment called the double slit experiment created some controversy in physics at the time, in which when photons or particles are shot at a slit, it produces a different result if you have only one slit or if you have two slits. And if you have one slit, you get the particle producing a particle pattern on the backboard.
Right.
And when you have
waves,
you get wave interaction. And this, like, baffled the physicists at the time. Although Duboglie and others shown that they could account for this in terms of fluid dynamics with an ether, nobody paid attention. Well, Einstein paid attention, but much later. It was kind of too late. But basically, everybody had got rid of the ether with special relativity and general relativity, and they didn't want to put it back in. And the result is that they abandoned mechanical wave functions to describe this particle. How could it be like a particle and a wave at the same time? How could it go through both slits and kind of interfere with itself to put an interference pattern on the backboard, and so then superposition, and like basically quantum weirdness was invented to deal with this experiment, where like all of a sudden particles were no longer associated with known mechanical effects. They were just like magical, and they could two places at the same time, and they could like have all kinds of functions, nonlinear functions, which they do.
Right.
I don't disagree with that. They do, because space-time is singular and wormholes written, and so particles can be non-local, have non-local information effect, and so on. The error that was made is to assume that, okay, now it's quantum weirdness, we can abandon all mechanical models, and you know, we're gonna just write the equations on probability functions. And you know, and that led to a whole branch of quantum mechanics which Einstein disagreed with very fundamentally, but because he was getting older at the time and so on, they basically discarded his opinion, and said that he didn't contribute much after general relativity, which is remarkable. But basically, all this behavior, and so then they tried, just the last thing, they tried to figure out, okay, well, maybe if we have a very precise measurement of the slit, we can see if the photon is going through one or the other, right? We can, and then when they tried to make the precise measurement, which is really important detail, that measuring device has to be tuned to the size of the slit, right?
Wavelength of the light too, right?
Right, and so if it's tuned that way, it influences the result, and you get the dots again. And so like that, you know, and that was described as the collapse of the waveform and so on. You know, with the Schrodinger cat in the box interpretation, where you don't know if the cat's alive or dead. The cat is in superposition state until you open the box, as if the universe is confused about the state of the cat because you are, right? You know, this is like, you know, excuse me, but you know, you might not know the state of the cat, but the universe, I'm sure, is not confused about the state of the cat. And, you know, which I'm saying in jokingly, but really, actually, papers have come out from famous scientists lately talking about, you know, that's kind of a problem. It's a fractional problem. It's like there's other frames of reference than the human that opens the box. Like, you know, there's a fractional problem. Like, what about the flea? What about the microbe, you know, in the box? What, you know, what are you picking as the observer, right? So, but all this goes away and starts to make sense if you don't assume, if you make one change in your assumptions. That is, when the particle is moving through the field, it's not in a field-free environment. It's not, the space around the particle is not empty.
Right.
It's full.
So you're talking like the ether again.
Right. And yeah, and the particle actually is a dynamic of the space itself.
Right.
Right? You're producing a little vortex in the space.
It's the Tao of space-time, you know, the particle and the ether, right?
Right.
Yeah.
Well, you know, in more modern terms, the vacuum fluctuations of the space. And so when the particle is moving, it's making waves. So of course it's a particle in a wave, right? It's not because it's in some esoteric dimension of, you know, insanity. It's because it's like a boat on the ocean. It makes waves. And then it's called pilot wave theory, by the way. And it's becoming more and more popular, and you can go to YouTube and see videos on pilot wave theory, because they've done it in little bags of fluids, where they get silicone beads shot at slits, and they get all the same results as the double slit experiment with fluid dynamics.
Wow, right.
Okay? And so, of course, then if you put a device in the fluid that's making measurements, you're making waves in the fluids.
Right.
So then those waves interfere with the waves that the particle is making, and so you get a different result again, right? So all of a sudden, it makes sense, right? You can actually visualize it, you can understand it, you can see it's not like some kind of quantum weirdness, you know, and it makes something.
distance. Right.
And actually, that interpretation is much more suited to describe the event of consciousness, meaning it shows that everything is influencing everything, because all baiting in that same field, it's all making waves in the field.
Mm-hmm. Right.
So
it's
so
almost
then,
like, do you know Walter Russell's work? I assume, right? You probably.
oh yes,
So
absolutely.
it's almost like, I mean, it's still above my head, but it sounds like he was sort of moving in that direction with his work. With his,
Oh, absolutely, yeah.
The gravity, light is magnetic light, right? Yeah, magnetic.
Right. And the structure of the vacuum, he described the structure of the vacuum very specifically to be tetrahedral and cubic, and so on. And he collaborated with Tesla, and Tesla was a very big proponent of ether theory, and he actually. Einstein changed his mind, almost 15 years after special relativity, where he, said, actually, my equations are invalid without an ether, they're not invalid, but inconsistent. So, I mean, and I think that Einstein might was maybe influenced by some of Tesla's writing and Tesla, statements. I don't know. I can't prove that, but certainly, he came back to the ether, and so was, and so was Tesla. And now, Wilczek finally, it's the first time really since a long time that such a prominent physicist in the mainstream, very clearly and straightforwardly states, that the ether theory is necessary for physics.
Cool. Wow. Excellent. And I looked at pilot wave theory. Thank you very much about that.
Yeah, check it out. It's amazing. More and more physicists are writing physics on it. It's taking over, but there's some resistance. You can imagine. One of them is a paper that was written. I didn't think it was a very good paper. I'm sorry, but recently, by some some of the progenitor of the physicists that were involved in the Copenhagen interpretation. I'm not gonna state any names, but that's trying to go against the popularity of pilot wave theory, which is not complete. It needs help for sure, but it's definitely, I think, a much more fruitful approach to the double slit experiment and the Copenhagen interpretation.
Excellent. Wow. Thanks, Nassim. I appreciate that.
Yeah, absolutely.
Happy holidays. Merry Christmas.
Thanks for your question.
Oh yeah, happy holidays. Happy solstice.
Yeah, definitely.
Great. All right, William, back to you.
There's something regarding the Copenhagen interpretation is a quote from Leonard Susskind, one of the preeminent most physicists over at Stanford University. And he opens one of his papers with this discussion on the Copenhagen interpretation that I think if everybody could internalize it, there'd be a lot greater clarity. And he says, it is obvious that the Copenhagen interpretation cannot be the last word. The universe is filled with subsystems, any one of which can play the role of observer. That's what Nassim just said. There is no place in the laws of quantum mechanics for wave function collapse. The only thing that happens is that the overall wave function evolves unitarily and becomes more and more entangled. The universe is an immensely complicated network of entangled subsystems. That was the point of our paper, the Unified Space Memory Network. We were describing the architecture of this immensely complicated network of entanglement and how it leads to cosmogenesis, baryogenesis, biogenesis, genesis of consciousness. But then he finishes the statement, only in some approximation can we single out a particular subsystem as the observer.
Very good. Very good that you bring that up, William. That's what I was referring to when I was talking about other physicists that are like coming to it, and that, you know, are being honest about, you know, what actually is at the base of the Copenhagen interpretation in quantum mechanics, and that it's significantly challengeable, you know, and incomplete, you know, that like it's you know, it's really hanging in midair, and it needs a base that is much more solid, and Sutskin is doing incredible work with others on describing this infinitely interconnected structure of space-time, which Wheeler, you know, John Archibald Wheeler earlier on had already been working on, and, you know, very early on, and, you know, was not really well understood, although Wheeler was collaborator to Einstein and, you know, one of the most prominent physicists in history. He single-handedly, you know, coined black holes and wormholes, and, well, actually black hole might have been one of his students, but you know, it's unclear, but you know, he definitely made it popular and so on.
It from bit, physics is geometry, the quantum space-time foam. He had a knack for coining terms.
Yes, no doubt, no doubt. I think to that list we can add now Wilczek. You know, we are children of the ether. Yeah.
He also says we are ethereal beings.
Right.
You know, on par with we're children of the ether.
Yeah.
Hey guys, I just put a link for people that might want to download your Space Memory Network paper. We have it on the website, so I just put a link in there since William mentioned that. Really amazing paper to read, and especially on this subject.
Yeah, it's so exciting. It's getting cited by many different teams in Europe, you know, and it needs some more work, of course, but it definitely is a first step in you know, connecting the space memory structure to the event of biology and consciousness. So it, you know, I'm excited that it's getting some attention.
Yeah. Hey, and for those of you who, I know there's some people that had to leave, they're asking if this is going to be recorded. Absolutely. These sessions are always recorded. We'll be sending an email out to our whole list. Everybody that signed up for this session, you'll all get it. So that you'll be able to listen to the rest of the Q&A if you need to go. All right, William, where are we going next?
This one, it's another great question. This is from Drew Seep. I believe the pronunciation is something along those lines. Drew asks, how does alpha relate to the atomic structure and electron cloud of the elements in the periodic table? I think I understand that in the Bohr atom, the proton is spinning at or near the speed of light, and the electron cloud is located at a distance that the spin has reduced to 137 times slower than the speed of light. Is that correct? And does that relationship relate to the heavier elements?
That's a good question. Okay, well, you know, I'm gonna try not to get too technical, but it's a technical question. Yes, so you have a reduction in velocity from the event horizon of the proton to the electron cloud at the Bohr atom. of 137 slower than the speed of light, or 1 over 137, but so alpha, and this, fine structure constant is a number that appears in physics that has baffled physicists for a very long time. It's like, why that specific number? Where is it coming from? And from the model that we've put together, Drew, it's nice to see you. Where are you from? Oh, you're muted. There we go. We can hear you now.
Hey, yeah, Rainier, Oregon.
Oh, Rainier, Oregon. Awesome. Nice to. Did we meet before?
In Egypt.
Oh, that's right. Awesome. Egypt was so awesome.
That was incredible.
Yeah. So so you can think of it as like a velocity change in the vacuum structure. So that, think of the atom as a Planck smoothie, right? It's like the Planck ether, and it's spinning, and it's producing boundary condition because of resonance, harmonic relationship. And so you can, at the protonic level, from the holographic mass solution, we know that the proton is like 10 to the 60th Plancks spinning together. So you can imagine a Planck smoothie. What I mean by that, like, the bits of the smoothie are really, really tiny, right? Because there's like 10 to the 60th of them spinning together, right? It's a huge amount, billions, trillions, and trillions of them, right? Makes a little proton. Because the Planck is so small, there's so many. But you can imagine, as you go out from the horizon of the proton, which is almost the speed of light, really, really close, right? At the mass of the proton, where we measure the mass anyway, out from there is the electron, right, at the Bohr radius. And so you can imagine that if you have an energy level or a mass of that much here at this velocity, right, that is the mass of the proton, when you go out, as the velocity drop, then the mass drop with it. And by the time you're at the electron shell, of the Bohr atom, at hydrogen, you have the mass of one electron, right?
Right.
So now it gets a little more complex after that. Because if you have two protons in there and two electrons and so on, the relationship change, the velocities change, right? Because you have a nuclei rotation plus proton rotation, right? So you have spin networks happening in the Planck smoothie, which you could think of literally as a galaxy, or as in this model. So so then think of it as like, okay, you have an electron and a proton, you have an electron and a proton, right? So now you keep adding them as you get into heavier and heavier particle. First of all, that model outputs properly the mass of the protons for all the elements of the table of elements, right? So, and we published that, right? Or we pre-published, right? So it's out there. The solution is extremely precise. It outputs all the elements. But you can imagine that as you get into heavier and heavier elements, where you get like a lot of protons all spinning, right? The radiation levels are going up because there's instabilities in the orbits, right? And all the smoothie, right, is becoming like more wobbly, if you'd like, right? And it has to do with the precession of the atom and the precession of all the particles in it, and all, like, so now you get states in which the Planck vacuum is actually radiating, and you get the radioactive elements, and you know, the decay and the magnetic force and so on, like the electroweak force and so on. You can see where that's going, and then you know, of course, in this calculation you're making, somehow the strong force should come out, right? And it does, right? That's what's in that paper, in the holographic mass paper. So you have this confining force, you have the centrifugal force, right? And you have the Coriolis effects of all this put together. And you can imagine that in the heavier elements, you get radiation in the Planck field. And we call that electromagnetic radiation, which is what Maxwell described, but Maxwell described it in an ether, which was removed, right? And linearized. He described it in quaternion equations in a fluid ether, using vortexes with little balls spinning around to describe the electromagnetic field. But since the ether was removed, it's kind of it's missing its base as well. So you don't know where the electromagnetic field is actually coming from, and where charge is coming from, and where electricity is coming from, electric fields. So electrostatic fields are unexplained. See, the consequences is deep, right?
Yeah.
Does that answer your question?
Yeah. Yeah. And I think it's absolutely brilliant that, you know, you determine where alpha, you know, 137 comes from. You know, I think Richard Feynman talked about it being, you know, this mysterious number from God or something. And,
right.
So I think it's absolutely brilliant that you determine where that comes from. I was just I understand the Bohr atom, it being 137, the electron mass being 137 times slower than the speed of light. I just didn't understand how that related, you know, how alpha relates to the heavier elements.
Yeah.
Well, you know, with multiple electron clouds, or, you know,
right.
shells.
Right. Because it you know, the radius of the rotation changes, right? As more and more electrons are involved, and so and then the ionizing energy is something we're working on. But at least so far we got all of the correct masses for all the atoms, you know, very precisely. So it's good. And you can imagine, so that, you know, as the energy goes up, well, you know, as well, you can imagine that the interaction of the atoms together, the electrons, clouds together of the different atoms, are producing like ropey, you know, interaction, connection, energetic connection between atoms, which produce the molecules. I'm talking about structure in the vacuum, in the Planck field, in the ether, that so that you get like bond angle relationship, you know, with the different atoms depending on their, you know, number of electrons and protons, right? And then the neutrons, which are protons in camouflage, basically, because when you knock a proton out of a nuclide, or a neutron out, what we call a neutron, out of a nuclei becomes a proton almost instantaneously again. So it's the relationship of the protons together that makes neutral particle, right? So so all this might be my mom calling me.
That's mine.
So yeah, so that was my answer.
It's brilliant. Thank you very much, Nassim. Happy solstice to you and all the delegates.
Thank you. I appreciate. Thanks for your participation.
Thank you.
Thank you.
All right, William. Amazing questions.
Yeah.
And you know, I think that one of the most important things about what the Resonant Science Foundation and Nassim's work does is, you know, bringing the realization that everything is connected. And so although we talk a lot about science, those concepts are connected to our personal lives and our social lives and our civilization as a whole, because it's all interrelated. And so there's a good question about, you know, taking it more from that science-centered discussion to something more applied to our personal life or even interpersonal life. This comes from George Dobson. He asked, what is your top tips for what we could all do to start making immediate impact on our lives and to inspire others to make changes?
Wow. Well, you know, based on my experience of the delegate program, I would say take the delegate program for immediate impact on your life. And if you have already, I would say, you know, I would say that my top one would be to spend time every day in quiet, you know, introverted state, to like spend time every day in, you know, exploring your internal self, which has infinite potential. And so to like actually connect with the vacuum from within you, you know, and even if it's like 5 minutes a day, or the first thing you do when you wake up, you know, for a few minutes, or the last thing you do before you go to bed for a few minutes, I think that would be probably one of the top one, is to actually connect with that field of information, connect with that energy, and bring that to your awareness, like to your consciousness directly, and then try to remain in that state of centeredness, of connection throughout the day as much as you can, which can be pretty challenging nowadays. So, you know, I think that's really my top tip for a transformative capacity, but as well to influence others, you know, just you know, be that the change you want to be, and like make that commitment. You know, you're gonna have bad days, you're gonna have bad months, you know, you're gonna have bad, you know, times and difficult times and all this stuff, but if you can be more and more in the state of awareness and the state of presence with people, with the people around you, you know, and to like, you know, discuss these things and discuss your views and discuss your connection with the structure of space, and be active, you know, in groups like this, you know, and be active in making decisions in your life that are supporting that direction that deepening of the connection, and whatever in your life that is not working for you, to make those changes so that you are able to like continue to grow in your discovery of yourself and the structure of the vacuum. Then you will lead by example. People will follow. You will have a larger influence. That influence, you know, of you going deeper into yourself every day. Even if you were in a cave by yourself and never saw another person, would have a large influence on the morphogenetic field of the whole planet. So don't underestimate the influence you have, whether you're talking to people or not.
Yeah. Hey, those of you that are still with us, which we have a lot of people, hardly anybody's left today, is at the very end of this call, Nassim's going to do a little visualization for us, which is really his opportunity to kind of share how he does what he just said, right? Like tapping in for a moment. So stay on, and that'll be towards the end of our call. All right, William Brown, we still have a little bit more time. We have like a half an hour, maybe 20 minutes, because we need to have our ending, but got time for a few more questions.
Well, there's no shortage of good ones, so let's try to get as many in as we can, I guess. This one is from Jeff Quintero, and Jeff asks, as there is no time, what replaces the three states of existence, past, present, future, within what is known as the arrow of time?
Ask that again.
So there's no time.
There's only memory.
Only memory in the structure of space.
Right.
That's probably the answer right there. But what replaces the three states of existence? So like, you know, we like to think that there's a past out there,
right,
in the present, and there's a future ahead out there.
Right.
What replaces that, you know, conception of an arrow of time if there is no time?
Right. Well, that's the thing. It's not replaced. It's abandoned, meaning there is the arrow of time that we experience, like the evolutionary structure that we experience, is really related to the position of things in the space, right? The position of memory in the space, the imprint of memory in the space. And the memory, because it's in a superfluid and superconductor, the memory, you're able to remember because it's linked to you, it's still, you know, entangled with you, those bits of information on the structure of space. And so you're really kind of like, and so you're really kind of saying that the past in that case is more like just information that's still present, you know, on the structure of space in those coordinates in space-time. So like to give you so now all of a sudden the arrow of time is linked to the mechanical functions of the universe. That is, you know, think of you going around the world, you know, as the earth is spinning, and then as the earth is going around the sun, it's making a spiral through space, right? Because the sun is moving. Imagine that you're leaving a trail of information along that whole spiral. And it's connected to you because it's entangled with you. All these bits of information are connected to your frequency experience at this moment, right? In which you're placing the information in space-time. You could think of it as like making a disturbance in a fluid, like as you move your finger in a fluid, you know how the particles all spiral behind your finger, right? You can think of that being the information you're leaving entangling with you as you're moving through the fluid structure of space-time, right? And that so that means that the reason why you can remember is because you're actually accessing information on the structure of space, and your present is actually the information, you know, that you're leaving in that moment, but it's influenced by the past because there's these eddies that are, you know, still producing, you know, their effect on the present. And then you can imagine that you can make some predictions about what the eddies are gonna do in the future, right? You could run the mechanics of what's happening forward and see a very specific evolution, right? That would, so it has some deterministic function where it's going, this whole vortex thing that you are, right? Of all these billions of Planck oscillators that are like doing their thing. And even physically, you're leaving some of these vortices behind, right? Because, you know, you're shedding, you know, trillions of atoms every second because cells are dividing at the rate of like 1 million cells a second, and you know, each cell is made of 100 trillion atoms. So, you know, you're leaving stuff behind even on the physical plane. And so basically this arrow of time and this evolutionary arrow is really the description of the vorticity or the fluid dynamics of space-time, you know, learning about itself, information transfer across this whole thing, right? Whether if for a planet, for a star, for a universe, or for an individual on a planet. Does that answer your question, Jeff?
Yes, thank you. It answers to me how you view it. I'm a philosopher, and I actually am working with a new theory that I have conceived, a new theory of value, and I have expanded Ken Wilber's integral approach.
All right.
And I am putting a proposal together for you to be able to integrate Ken Wilber's work on consciousness with your work and Roger Penrose's quantum consciousness, and thinking that the idea that the present, what we call the present, being actuality, begins at the collapse of the wave, from wave to particles, and then from there you have, I think that you call that singularity at the quantum level. That's that. Let's say that begins the present time. Before that, we can say that's the future, which are the probabilities, which are the possible and the potential emerging into the singularity, which is the collapse of the wave. And then what we are experiencing as this passing of the time is the potential energy emerging into actual, and this actual, that experience of potential to actual is what we then interpret as this arrow of time, and which we of course experience as in memory as it's time, because this is the experiences that we're having. So I look at it from that philosophical point of view, and I think it complements very well. It complements very well what you're doing, and I wanted to understand how you saw it. Which is very difficult for me because I do not quite understand the unified physics from me being part of the whole universe. As the universe is rotating and spinning, I am with it as well, because all of this information is also emerging through me, and then the information becomes light, and it becomes energy, and it becomes matter. So my experience, right, is basically, my experience is just simply part of being a whole part of whole humanity, which is all part of the whole universe. So I look at the world as a holonic structure. So I wanted to understand how you saw that, and I've looked at your answers on on the idea of time. And I think what you're doing with this understanding that we need to replace time with memory is one of the most breakthrough understandings, so we can integrate consciousness, spirituality, and the physicality of our universe. So
thank you.
Huge
Yeah,
admirer.
Yeah, you know, the important part to remember is, as you know, is that it's not a linear function. That is nonlinear functions are involved, because when you look at the protons that you're made of, right, your current experience of matter, you find that it's entangled with all the other protons in the universe. That is, the mass of the universe is present in terms of Planck energy, in terms of information in each proton. So it's holographic, right? So your evolutionary path through space, your, you know, arrow of time through space, is really an information network that you're feeding to the whole, which is feeding you back your experience, which you're feeding back to the whole, you know, and that feedback, feed forward structure, right, is what's driving all this evolution at all the scales. And that's why eventually the system can get, the little vortices can get so complex, and they be able to like have so much information crunching capability that it becomes self-aware, because feedback is already in the mechanisms of the structure of space-time. And the only difference between what I'm saying and what Ken's saying and others is that the mechanics are not the standard, you know, Copenhagen interpretation of the collapse of the waveform. It's a little different than that. And, you know, but it's similar, is just that the way it's imprinting on the structure of space is not under the collapse function, as, you know, as was pointed out by Sutskin. It's not, you know, there's nothing in the equation, even in the standard interpretation, that says that it's collapsing. It's basically saying that it's entangling as it gets more complex. It's entangling with more and more as it moves forward. It gets more complex.
Great. A kind of a follow-up. All the information that is emerging from within me, meaning from within my organism, my cells, my molecules, my subatomic particles, all the way to the Plancks. Basically, I am connected to the source of the infinite at the Planck level when mass begins, which prior to that is the source of all the information. So at that level, information begins to emerge at the Planck level, and that's the first boundary to location that I have. But then all that information emerges through everything that is part of me, and then also have a boundary, a local boundary that is me as an organism.
That's right.
Is that correct? Is that view correct?
Yeah, exactly. It's the collective behavior of all that information, 100 trillion cell plus multiplied by 100 trillion atoms that makes each cell, multiplied by all the protons and electrons that makes each atom, multiplied by all the Plancks that makes each of these particles. And, you know, and that's all the information network, right? That's transferring at each level of the scale. And as it transfers, right, it produces different physical phenomenon, right? Atoms that gets together, that makes molecules, that gets together, that makes cells, that gets together, that makes organs, that makes, you know, you as a collective behavior of all the cells, right? They all organize, they all function together. It's not just like a big mess of cell, right? You know, that whole, that is all structured by the information network that's emerging from the vacuum that eventually you call you.
And then if we continue with that, then me as a whole part of humanity as a whole, then I am basically a whole part of humanity as a whole. And then this reality that we have constructed, which we have organized in the past, present, and future, is simply because we're interpreting this information. But
that's why I was mentioning the mechanics of, you know, you in the world, in the solar system. The solar system is part of the galaxy part of the superclusters, and so on. So it's like a fractal information network that you're embedded in.
And then this also corresponds with the idea of that being all spiritual, and that the source of spirit is in everywhere, is because we are connected. We contain all the information already, and at the level of the source, at Planck level, there we're entangled. So everything is entangled because so the concept, I come up with the concept of omnicentral. So I am the center of the universe.
Right, that's right.
As every plank that is within me is at the center of the universe.
Every scale, you know, is a fractal center of universe. So basically, that's very good. And you know, when you look at it this way as well, then you can understand why, you know, so many masters talk, you know, when they talked about spirituality, they talked about going inwards, you know, and going to the source. And literally the source of information is what actually produces your physical world, and your physical existence. So, you know, it's nothing different than what was said by all these people, is just that nobody, I mean, in general, people didn't write the math for it or write physics on it. And when you write physics on it, it actually works. It does the right thing. It says the right thing. It comes up with the right answers. So it's remarkable. And it modifies the standard view of physics dramatically.
Thank you so much. Thank you, Jeff. Thank you so much. Look forward to hearing more about your work. And Nassim, you know, this is not the first time that we've heard about somebody applying your research work and Ken Wilber together. I know we were contacted by Wisdom University hoping to bring the two of you together in a discussion with their community. Seems like maybe there's something there before we lose Ken from this world. I know his work will continue on, but I think that might be something for us to look into. It keeps popping up.
I would love that. That would be great. Yeah, we got to make that happen.
Yeah, I'll follow up with them. I think that's an important, it's kind of like one of those legacy pieces I think that we need to bring in together.
Absolutely.
Yeah.
Another question, William? Do we have time?
Well, let's slip in one more.
Okay.
So this one might be a little bit more on the metaphysical side.
Okay.
You know, I know we try to keep it pretty pragmatic, but you know, what's that?
But it's Solstice, so let's.
It's Solstice, and you know, I think the community of researchers and learners that are tuning in with us, let's say they understand that there's perhaps more to the universe than what the mainstream presumes. You know, so I think there are questions that are legitimate to explore. But anyways, the question comes from Aditi Singh. Yes, I don't know how relevant to the cosmological research that you undertake this question is, but could you shed some light on the science behind out-of-body experience and the astral body?
Wow. Oh, that's a good question. You know, I mean, that's the thing. That's the cool stuff that comes out of realizing you can't get rid of the ether in physics. and put it back in, or vacuum fluctuations, and which are in quantum field theory, but that's been ignored largely. But basically, it says that, well, it tells us that, like, what else is going on in the vacuum? If you're an information network structure, we know information that cannot get lost, right? So it can only continue to evolve. So that says something deep about, life after life, for sure. If you're in an information network, then since information cannot disappear, actually, when people say people die, nothing really disappeared. Meaning all the atoms they're made of, all the stuff they've ever been made of is still on the planet somewhere, or off the planet if it flew off in some tornado, or, it has a lot of potential to describe, what people describe as out-of-body experience, and experiencing their consciousness in non-local area, non-locally, meaning, experiencing their body being, I don't know, laying in bed or sitting somewhere, and at the same time experiencing, being in a facility, across the world from where they are, and being able to describe it, what the people call remote viewing, like all these things that some of them have been explored more than others and confirmed more than others. Like certainly remote viewing has been confirmed and published in peer-reviewed journals that are very serious physics journals, the best ones, all the way back to the 70s, I believe. But certainly, out-of-body experience and all this can start to make sense. And I always say this, it's like spirituality is just physics we haven't understood yet. Like what spiritual phenomenons that people have had, experiences that so many people have, that they might only have them once in their lifetime, or they might happen quite commonly. They don't necessarily pay attention to that. For instance, what people call déjà vu experiences, or you think of somebody and all of a sudden they call, and they haven't talked to you in a year, things like that. And, like these little hints almost that life gives us along the way, that what's visible is not the whole thing. And actually, from the physics we're discovering now, in fact, what's visible is only, a very small part of what is, which is the vacuum energy, which is much larger. And really, the material world is just like a little small, teeny dynamic of what's actually there. And so that starts to really answer those questions at a deeper level. And I think that it's absolutely appropriate to think about it in terms of science. It's just difficult to discuss it or to think about it in terms of science, because it has a tendency to not be well received by the current institutions. But it's not like it's not happening. It's not like it's not been measured in some cases. And it's certainly not because it's, people are not having those experiences. They are having those experiences, and those experiences are very valid experiences. And I think they're telling us something about our nature that's much deeper, about our capacity as well to interact with the vacuum consciously, and to influence the vacuum, to influence the ether, what I call vacuum engineering, you know, and I think it's important for people to know this. It's not necessarily some voodoo thing, you know, in some kind of spiritual realm. It's very much tied to the physical and to the way physics works to produce the physical realm.
Nicely said, Nassim.
Thank you.
Hey, I'm just going to do a quick, some links. We're just coming to the end of the call, and we're going to have Nassim do just that little visualization of just what he's been talking about, which I always love when you do that, Nassim. And each time we do it, it really deepens my practice of every day tuning in to that singularity inside of me and my impact. It changes my sense of responsibility in the world and my impact in the world. And so anyway, you guys will be excited if you haven't done that, or if you have, this is a really nice opportunity to dive in again. So a couple things. It's winter solstice. Again, it's so nice to have you guys join our virtual classroom. We love opening it up every quarter so that you can come in. And this is a time where you can support what we're doing by either contributing to the Resonance Science Foundation or participating in one of the things that we have going on. So I'm just going to put a few links in. One, that year in letter I told you about that has some of the things that we've accomplished this year. You'll see a link there. And if you want to support the foundation in some way, even if it's a small amount, the energy of your participation, helping us get the research team expanded and growing and all of that, is really important. And if you have some resources, if you like to do your year-end gifts, please consider us as part of that. And then we have a special with our electives. There's 4 of them that got launched this year. As I was saying, William Brown. We have 2 with, I've got my nephew in the background. I just brought him to Costa Rica with me, so he's back there. We have 2 with Robert Grant, and we have 1 with Jamie Janover. I'm putting a link in there now. And if you go there and would like to do one of the electives, we're offering 20% off between now and the end of the year with this coupon code that I just put in there, electives20. So it's just an opportunity. If you haven't gone and explored one of those, gives you a chance to do that and get a little savings as a gift from us. So please check that out. The other one that Brian mentioned is that we have these 3 events that are coming up. And so this link right here will give you a little information about those 3 events and a way for you to put your name on the email list, because we'll be sending early bird information about signing up for the Master Series to Easter Island, to the exciting delegate retreat happening in July, and then also our next mission to Teotihuacan and other sites in Mexico. So there's a link for you to be able to do that. Peru, we told you about Peru. Face the Current, who's a magazine, travel magazine. They came with us and took pictures and are writing stories. In their winter issue, we're going to be featured on the cover, 16 to 24 page spread. You'll be able to see a lot of what happened for us. And they've given us a special discount. If you put this coupon code in, RSF15, you can save 15% on their subscription. So get this magazine. It's going to be really cool. We had such a great time, and it was a magical mission for us. And the last link I'm going to put in here, which is super exciting, if you've been thinking about getting an art crystal for yourself or someone else, Art Crystal announced just yesterday that starting tomorrow for 3 days, you can get $256 off a crystal. So if you click that link right there, you'll see that. And following that, if you miss those 3 days, there'll still be a discount code on there after those 3 days to get a crystal. So those are some of the ways that you can support what we're doing, whether it's giving a donation or participating in one of our exciting things. And then the last thing would be to join the Resonance Academy. If you want to check it out and be able to come on these calls on a regular basis, we would love to have you part of the community. And let's bring some more young people like Eddie. So excited that we got Eddie homeschooling and he's learning this stuff. So really great to have you on board, Eddie. And I love all of you. This is such a great community, and we are getting ready to grow and make a real difference. So come and join us this year. There's going to be lots of fun ways to do that. So, Nassim, we got a few minutes left, and obviously there's some interest in this. Like, really, how do we begin to accelerate and amplify our experience of our connection with this field and our impact? And I know you do a beautiful job in guiding us into that.
Yeah, thank you. I just I was reading the comments. I was having fun. It's so cool to see everybody's contribution, and I love it. It's like so many beautiful people out there, and amazing thoughts and comments, and I think that we can really make this world utopic world if we all work together, and that's critical at this point. And it's changing, and we can get a little impatient with the change. I certainly do, at times, but at the end of the day, and I have to remind myself all the time about that, the main thing I need to change is myself and grow. And I'm doing that as best as I can, and I fail a lot of times. Do my best with my children, with my work, with everything I do, and it can be challenging. But at the end of the day, if we can keep our eyes on the 8 ball and keep manifesting what we want in this world, and how we're gonna grow into a galactic community with capabilities that brings us to the stars, then we can do that. We have everything we need to do that, and we have to pull together and be strong together to make that change, to make that difference. So thank you so much for your participation. It's deep from my heart. Thank you for everything you all have done in 2018 that makes it possible for us to still be here and to be providing this to you all, and interacting with you all. So just to finish our solstice time together and our year, maybe a little bit of inner perspective, if we close our eyes and if we take 3 deep breaths. Exhaling by the mouth and letting go of all of the stresses in our body. And just on one of the breaths, just going inwards with the air, with the breath into our lungs, becoming aware of the lung barrier and the exchange with the blood, and then traversing the blood air barrier into our bloodstream in our consciousness, and becoming aware of our whole body, all of our extremities, every cell of our body that the bloodstream touches, and then into the whole envelope of our body, just becoming aware of all the cells in it, and all of the natural dynamics that are occurring in those cells, each one of them. And then becoming aware of all the molecules that makes up the cells, like a geometric metric of your body. Feeling the energy interaction of all these energetic geometries of the molecules, each one powered by the atoms that makes them up, and the energy of every one of these atoms, and the protons at the center, the fluid dynamics of space-time, the speed of light. And so seeing your body as a light being that produces the geometry of the molecules. And then seeing the influence of that light being on the vacuum structure around you, on the Planck smoothie around you that you produce, the vortex that makes you up. Centered by your center of gravity and by your heart, you know, like feeling your heart at the center of that light bubble in the structure of space-time that you produce. Coming in resonance with that fundamental oscillation of space-time. And within that state, within that place of connection, within that place of rest and deep knowing of yourself and the world around you, within that place of mastery, we visualize 2019, we visualize this transition in this moment of solstice for our evolution as a fundamental transformation for our world and for our life in it. And we visualize 2019 as a very important transition into a larger awareness and a larger amount of information flow, a larger influence of our galactic community, and a larger influence of our morphogenetic field on the local Planck field, more light on the planet, more harmony, more connection, less dissonance. And we make this our New Year's resolution for our private life and for our world. Thank you so much, everybody.
Thank you so much, Nassim, for spending this time with us every month, and especially on these quarterly calls for the public and the solstice and the equinox. Really appreciate your time, and it was really a blessing. You can see from all the messages in the chat, everybody just loves you so much, and so appreciates this conversation in this community. And William Brown, thank you so much for coming on and doing the questions today. I really appreciate you. And I hope people check out your Big Questions course, because I'll say that when I came to your breakout groups afterwards and people talked about what they got from your course, a lot of this sense of who am I in relationship to this unified field, people felt like they got something very different than they had in the past and were really able to apply it. So I really encourage people to jump into the Big Questions course. It's fantastic. And thanks again for your time today.
It's my pleasure. And, you know, certainly that's part of the aims of the Big Questions course, was to bring these unified physics concepts, or unified science, that is, and bring it in such a way that you could see how you are connected to that. So it's definitely great to hear that people were having that experience.
Yeah, fantastic. And I want to also thank Emily, who's behind the scenes. She's like recording, getting us on Facebook Live. We have a great team that's been helping out. So I just want to say thank you to everyone, and come and play with us in 2019. We can do this together as a community. Thank you so much. Happy solstice, everybody.
Happy solstice.
Have fun skiing, Nassim.
Thank you. It'll be wonderful to ski with the kids again.
Yeah. All right. Bye, everybody.
Bye, everybody.